Here we have a SAT math question. Okay, let's go to the information. If m and n are positive integers, so that m to the nth power equals to n to the mth power and n is equal to 18m, then what is the value of m to the 17th power times n to the 34th power? Okay, here we have two information. There is m to the nth power equals to n to the mth power and n equals to 18 times m. Okay, now let me take the first information. That is m to the nth power equals to n to the nth power. So now let's consider the second information, that is n equals to 18m. So I can plug in this 18m for n. So in this equation, I'm going to plug in 18m for this n and this n. So let me do it. Then I'm getting m to the power of 18m equals to 18m whole to the power of m. Okay, here the exponent, two quantities are multiplied, two values 18 and m. So whenever two values are multiplied at the exponent, one of the values can be taken as the exponent for this base m and the second value can be taken as a whole exponent. So I'm going to take this 18 as the exponent for this base m, then I'm getting m to the power of 18. Now I'm going to take this second value m as a whole exponent, so equals to 18m whole to the power of m. Okay, now two terms are equal with the same exponent m. Whenever two terms are equal with the same exponent, we can equate the bases using one-to-one property. So when I equate the bases, I'm getting m to the power of 18 equals to 18m. Okay, now let me subtract 18m from both sides. When I do so, the positive 18m, negative 18m will cancel out. And on the left side, I'm getting m to the power of 18, negative 18m equals to 0. Okay, now let me take the equation over here. That is m to the power of 18, negative 18m equals to 0. Okay, now let's factor this expression. The greatest common divisor for these two terms is m. So we can factor m out. If I factor m out, I'm getting m to the power of 17, negative 18 inside the parenthesis equals to 0. So the multiplication of these two terms equals to 0. Whenever the multiplication of two terms equals to 0, either the first term is equal to 0 or the second term is equal to 0. So if I equate the first term to 0, I'm getting m equals to 0. If I equate the second term to 0, I'm getting m to the power of 17, negative 18 equals to 0. But this is not possible because m and n are positive integers. So since m is a positive integer, the value 0 for m cannot be accepted. Okay, now let's consider this equation, and if I add 18 to both sides, I'm getting, so let me cancel this, then I'm getting m to the power of 17 equals to 18. So from the second equation, I got m to the power of 17 equals to 18. Okay, now let me take the expression for which we have to find the value. That is m to the 17th power times n to the 34th power. Let me write this over here. That is m to the power of 17 times n to the power of 34. Okay, already we got the value for this m to the power of 17, that is 18. So we can plug in 18 for this one. And for this n, we know that 18m, that is n equals to 18m. We can plug in this 18m for the n over here. Then I'm getting 18m whole to the power of 34. Okay, now 18 times. So here two values are multiplied and we have the common exponent. Whenever two values are multiplied and we have the common exponent, the exponent can be distributed to each value. Then I'm getting 18 to the power of 34 times m to the power of 34. Okay, let me continue over here. So 18 times 18 to the power of 34 times m to the power of 34 can be written as m to the power of 17 times 2. That is, this 34 can be written as 17 times 2. Now let me continue. 18 times 18 to the power of 34 into, here two values are multiplied at the exponent. So one of the values can be taken as exponent for this m, and the second value can be taken as a whole exponent. I'm going to take this 17, the first value, as the exponent for this m. Then I'm getting m to the power of 17. So now I'm going to take this second value 2 as a whole exponent over here. Now 18 times 18 to the power of 34. Already we got the value for this m to the power of 17, that is 18. So we can plug in this 18 for this m to the power of 17, and I'm getting 18 square. Okay, now, so here three terms, three values are multiplied with the same base. So here we have base 18. We don't have exponent for this 18. So whenever there is no exponent, we have to consider, we have to assume there is exponent 1. So now there are three powers multiplied with the same base. Whenever we multiply two or more powers with the same base, we can take the base once and we have to add the exponents. So then I'm getting 1 positive 34 positive 2. Then I'm getting 18 to the power of 1 positive 34 is 35, 35 positive 2, 37. So I'm getting 18 to the power of 37. I got the value of the expression m to the power of 17 times n to the power of 34. Its value is 18 to the 37th power. We find this 18 to the 37th power in option B. So the correct answer choice for this question is option B.